The objective here is to describe what the Intel manual says about rounding. So they begin with, when performing floating point operations, the processor produces an infinitely precise floating point result in the destination format. And there's your three floating point encodings we've covered before. Whenever possible, so it's going to be infinitely precise whenever possible. So one way to think about that might be, well, if we have a floating point number like 1.2, and then there's zeros that go on infinitely, well, okay, that's exactly precise. But if we have something like pi, where those numbers repeat without a pattern, then it's not infinitely precise because that is an impossibility. Well, they go on to say, however, because only a subset of the numbers in the real number continuum can be represented by this format, it is often the case that an infinitely precise result cannot be encoded, of course, in the format of the destination, so no surprise there. They give us an example. The following A has a 24-bit fraction. The least significant bit of this fraction, which is underlined, cannot be encoded exactly in the single precision format, which only has 23-bit fractions, or bits in the fraction. So here's A, and right there, underlined, is the bit we are trying to round. So to round this, the processor first selects two representable fractions, B and C, that most closely bracket a value. So I don't know why they use the word bracket, but I've circled them right here. So we could go with 0, 1, 1, or we could go with 1, 0, 0 in order to round this one bit. Now, how do we choose? The Intel manual makes it pretty, this is a pretty good description right here. It says that the processor then sets the result to B or C according to the selected rounding mode. So you, the user, you have some control over this. Or maybe I should say you, the programmer. Rounding introduces an error in a result that is less than 1 unit in the last place, so the least significant bit position of the floating point value to which the result is rounded. So there's our first question. How does the processor know which fraction? Well, here we can go into our 4 options. It says the standard 754 defines 4 modes. So what are the 4 choices in rounding modes? We got our nearest, we got round up, round down, and round towards 0. Now the default rounding mode is round to nearest. This mode provides the most accurate and statistically unbiased estimate of the true result and is suitable for most applications. So there's a question for you. What is the default rounding mode? And let's dive into that using this table here. So round to the nearest. Rounded results is the closest to the infinitely precise result. If 2 values are equally close, the result is the even value. That is the one with the least significant bit of 0. And then they just simply say default right there. The next mode we could go with, and it looks like this is how we set the modes using RC field setting. RC stands for rounding control. So to round down, this result is closest to but not greater than the infinitely precise result. Round up toward positive infinity. The next one is round towards 0, which is truncating, I guess. Rounded result is closest to but no greater in absolute value than the infinitely precise result. So way to make something as simple as rounding pretty complex, Intel. The round up and round down modes are termed directed rounding and can be used to implement interval arithmetic. So the question is, what is directed rounding? And the answer is the round down and the round up modes are directed rounding. I guess because you're going in a particular direction, up or down. So what is interval arithmetic? It is used to determine upper and lower bounds for the true result of a multi-step computation when the intermediate results of the computation are subject to rounding. So I feel like we're getting out of my realm of expertise and deeper into mathematics. With a round towards 0 mode, sometimes called the chop mode, that's cool, they got their own slang. Don't be offended if you're a nerd, I was just kidding right here with nerd slang. That reminds me of this meme I saw of Data from Star Trek The Next Generation, where the meme said, "No need to apologize. I was not offended." So before going on, let's just turn that into a question. What is chop mode? And you can say it is slang for round towards 0. And that makes sense now that I think about truncate and the whole concept of rounding towards 0 being called chop mode. Well, this is commonly used when performing integer arithmetic with the x87 FPU. Well, the rounded result is called the inexact result, and when the processor produces an inexact result, the floating point precision inexact flag is set. And I guess they call it the PE flag, maybe for precision exception. So you got this precision exception flag set when it's inexact. Now, the rounding modes have no effect on comparison operators, operations that produce exact results, or operations that produce NaN results. So there are 3 scenarios when rounding modes are completely irrelevant: when comparing, producing exact results, and producing NaN results. Well, let's get through this next section, and then we're done. Rounding control fields. In the Intel 64 and IA32 architectures, the rounding mode is controlled by 2-bit rounding control field. We can see that in table 4-8. The RC field is implemented in 2 different locations. So you'll have one in the x86 FPU control registers and the MXCSR register. Although these 2 RC fields perform the same function, they control rounding for different execution environments within the processor. The RC field in the x87 FPU control register controls rounding for computations performed with the x87 FPU instructions. The RC field in the MXCSR register controls rounding for SIMD floating point computations performed with the SSE and SSE2 instructions. So here's our last question for this video. What does the MXCSR register control? And I thought it would be interesting for us to Google x87 FPU instructions. I found myself on another Intel page here. And yes, we're going to go ahead and just completely skip this 4.8.4.2 paragraph. But maybe sometime in the future I could dive into this x87 document, maybe after the manual, that 800-page beast we're working on right now. Whoops, I meant 400, almost 500 pages, and that's kind of cool to think we're already on page 104, so we're almost there. But anyways, check out their register. And though I'm tempted to start diving into this right now, I'll just have to save it for a separate video. But I thought it'd be cool for you just to take like a brief look. And check this out. This table is table 4-3 from the Intel manual we're reading right now. We haven't talked about flush to 0, but we did just finish talking about that MXCSR registers. So good times. Maybe I'll get into this in the future. But for now, thank you for watching.